Have you ever just felt exhausted by modern web development? I mean, if you're building software today, you know exactly what I'm talking about. We've somehow accepted these massive, heavily abstracted, multi-layered systems as the default. Think about the pipeline. We query raw data, hydrate it into an ORM, serialize it into JSON, ship it across a network, deserialize it, map it to client-side state, and then eventually, hopefully, render it to the DOM. It is an exhausting pipeline, and for rapid application development, or RAD, this JSON tax is just a massive drain on your velocity. So welcome to this explainer. Today, we're going to explore a really fascinating architectural inversion, the NSPH stack. We're looking at a structural rebellion against all that modern bloat, a way to collapse those layers and actually bring some joy and speed back to building software. Here's our quick roadmap for the explainer. We'll start with the 7-layer React bloat, then meet the NSPH stack itself. After that, we'll unpack 2 massive hacks, views as contracts and the HTMX transport layer. Then we'll check out the micromouse UI topology, and finally, wrap things up with the 64-4 efficiency rule. Section 1. The 7-layer React bloat, the real cost of the modern orthodoxy. Okay, let's dive right into this. When you look at the standard enterprise stack, you've got about 7 distinct layers, from the database to the ORM, over to the API, then the JSON transport, front-end state, virtual DOM, and finally the actual DOM. Now here's the thing. Every single handoff between those layers is a trust boundary. It's where latency hides, where data shapes randomly mutate, and where renaming one tiny field can break 3 completely different files. Now contrast that with the NSPH stack. It compresses that whole shebang down to just 3 essential layers: database view, PHP shuttle, browser DOM. That's it. The surface area for bugs absolutely plummets, and that is exactly what we mean when we talk about an architectural inversion. Now, let's be absolutely clear here. React is phenomenal. If you're building a highly complex, client-heavy app, something like Figma or a collaborative document editor, you absolutely need that robust state management. But let's be honest, for standard internal tools, dashboards, and your basic CRUD applications, which, let's face it, is the vast majority of rapid application development, it often creates a massive tax before it ever creates leverage. You're suddenly stuck maintaining multiple definitions of the exact same data model across the backend, the API, and the front end, not to mention fighting hydration mismatches and endless schema disagreements. Section 2. Meet the NSPH stack. Nginx, SQLite, PHP, and HTMX. So the whole defining philosophy here is to push your data and computation as far back toward the server and the database as possible. Every single technology in the stack has one strictly defined job, 0 philosophical confusion. Nginx? It's your fast, boring, totally dependable front door. SQLite is not just a storage file, it's this embedded powerhouse that actively shapes truth without any network latency. PHP steps in, not as some bloated framework, but just as an atomic, request-oriented data shuttle. And HTMX, it handles the dynamic DOM patching right there in the browser. All right, Section 3. Hack 1, Views as Contracts. Guarantee before sending. This is, without a doubt, the most profound structural hack in this entire methodology, the concept of a pseudo-object. In this stack, we have a hard and fast rule. PHP never touches base tables directly, ever. Instead, it queries SQL views. Think of these views as pseudo-objects. They give you a stable name, a guaranteed sequence of fields, and clear responsibility. Basically, you get the awesome benefits of interface segregation, but applied directly to relational data. PHP doesn't have to guess how to assemble a complex contact card. It just asks the database, and the database hands back the fully shaped object. Guarantee before sending. I just love that. It's a punchy maxim that drives the entire data layer. Contrast that with what we usually do today, the weak, super error-prone receive-then-guarantee model of modern APIs. In a JSON-heavy architecture, the front end gets this fuzzy payload and then has to run all this defensive logic. Are the keys actually there? Did the types change? Is something randomly null? With the NSPH stack, the database view contractually guarantees the result set before PHP even sees it. The benefits of this hack for rapid application development are just immense. You're getting positional consistency and native type enforcement right at the database engine level. You can overload those views with derived fields, like say days underscore until underscore expiry, and PHP just loops over the fully formed contract. 0 complex logic needed in the middle. But the real game changer? It enables purely headless development. You can actually build, test, and completely refine your semantic data layer straight in the SQLi CLI, way before user interface even exists. Section 4, Hack 2, HTMX Transport Layer, eliminating the JSON tags. Let's walk through this data loop. It is hyper-fast and elegantly simple. Step 1, your user clicks a button in the browser. Step 2, HTMX fires off an HTTP request to a PHP endpoint. Step 3, PHP queries that optimized SQLi view we just talked about and instantly binds it to a native HTML template. And Step 4, HTMX gets that pure HTML fragment back and just swaps it directly into the DOM. Notice what's missing? No complex React component lifecycle, no heavy client-side router, no state hydration. So the absolute kicker here is this. JSON literally does not exist in this stack. We aren't wasting CPU cycles turning database records into text strings, sending them over the wire, and praying the browser interprets them back into objects just to figure out how to render some divs. The system sends exactly what the browser natively understands and needs, pure HTML. Because we aren't duplicating the object model and there's no hydration mismatch to untangle, interface transitions happen in sub-10 milliseconds. It literally feels instantaneous to the user. Section 5, the micromouse UI topology. Roundabouts versus trees. You know how traditional folder-style software forces you into this rigid tree topology? You start at the root, click into a section, drill down into a subsection, and finally find your record. It dictates one official path, which almost always leads to orphan records, getting lost deep in the system. But real, human workflows, they're associative. The NSPH stack enables what we call a roundabout topology. Because the backend views aren't permanently locked to one specific rigid screen, users can enter from anywhere and fluidly navigate to anything related. This brilliantly sets up the micromouse concept. Just like a little micromouse instantly finding the smartest path through a maze, HTMX effortlessly pulls in independent, view-backed HTML fragments exactly when needed. If you're looking at a property screen and suddenly need the owner info, HTMX just loads the owner card right there in line. Looking at a phone number, it pulls the contact summary. It strips out so much navigation friction. Plus, because we can spin up explicit views for orphaned items, invisible data rot basically becomes a thing of the past. Section 6, the 64/4 efficiency rule. Maximizing leverage in RAD. 64/4. This right here is the ultimate efficiency standard of the NSPH stack. Honestly, it's like the 80-20 rule, but on steroids. The idea is to identify the absolutely essential 4% of your structural layers and architectural decisions that are actually responsible for 64% of your application's agility, stability, and speed. By ruthlessly stripping away every layer that doesn't add immediate value, you get maximum output with the fewest possible moving parts. So bringing it all together, that vital 4% boils down to these 4 pillars. SQLite views acting as your unshakable, rock-solid data contracts. PHP stepping back to serve merely as a thin, atomic transport and rendering layer. HTMX handling dynamic HTML updates directly in the browser, and Nginx standing guard as your stable front door. That is the absolute beautiful minimalism of this stack. Everything else, your Kubernetes clusters, complex state managers, heavy GraphQL APIs, they are completely optional until you can prove they are strictly necessary. Which leaves us with this final, somewhat provocative question to chew on. When you look at your own modern stack, is it actually creating leverage for your development speed, or is it just creating a tax? The NSPH stack is proof that sometimes collapsing the layers and letting the database be the true, intelligent core is actually the fastest way to ship reliable, high-performance software. Thanks so much for joining me for this explainer. I really hope it sparked some fresh, minimalist ideas for your next big project.